Hi, I'm Samy, and this is PoisonTap. PoisonTap is a combination of software that lives on a $5 Raspberry Pi Zero and the internet. When plugged into a locked or password-protected computer, it takes over all internet traffic momentarily. It siphons and stores all HTTP cookies for the top 1 million websites. It exposes the internal router to the attacker, making it accessible remotely. It also installs a web-based backdoor in HTTP cache for hundreds of thousands of domains, and it works even when a computer is password protected. The backdoors and remote access persist even after the device is removed and you walk away. First, let's see it in action, and then we can go into the details. As PoisonTap is being plugged in, several things are happening. Although this machine is unlocked, the same attack will work when the machine is running and password protected. Here I unlock it to show you what's happening. The machine powers PoisonTap through its USB, and when PoisonTap boots up, it emulates an Ethernet over USB device. As soon as the computer detects this, it assumes there's Ethernet plugged in, and it automatically attempts to make a DHCP request out to PoisonTap. PoisonTap returns an IP address. Normally, this would behave as a secondary network interface, but PoisonTap crafts the DHCP response to make it appear that almost all IP addresses on the internet are actually part of PoisonTap's LAN. This forces your computer to start sending internet traffic out to the device instead of the internet. Now that PoisonTap can intercept network traffic, as long as a browser is running on the machine and an HTTP request is made automatically, such as through an ad, AJAX request, or other dynamic web content, which happens on most sites even when the browser is entirely in the background, PoisonTap intercepts the request and responds with attack code that's interpreted by the browser. Once executed, the code launches 1 million hidden iframes to the top million websites, simultaneously stealing all cookies being sent to the websites. A website can avoid PoisonTap from stealing its cookies by using the secure flag on cookies and only allowing HTTPS. After exfiltrating cookies, PoisonTap cache poisons each domain, indefinitely force caching a web-based backdoor that produces a WebSocket out to a command and control server run by the attacker. Whenever the WebSocket is open, the attacker can remotely send commands to the victim and force their browser to execute JavaScript code. The attacker is also able to acquire same origin policy by producing iframes in the attack for the domain the attacker wishes to gain same origin on. This allows the attacker to make requests as the user with the user's cookies and view the responses with no visibility to the user. Additionally, the Xframes options header is ignored, allowing you to generate iframes on non-iframeable sites, as the HTTP header is previously cached from the malicious PoisonTap response. HTTP-only cookies that wouldn't be accessible via JavaScript are also accessible, as they're sent along in the HTTP header to PoisonTap. PoisonTap also uses DNS rebinding to plant a cached backdoor on a hostname that temporarily points to the IP of PoisonTap, but once unplugged, points to the IP of the router. This allows the attacker to remotely access the victim's router, and I provide a public DNS server that performs specialized access to demonstrate this. The last thing PoisonTap does is poison the web cache of common CDN libraries, such as Google CDN, for all major JavaScript frameworks such as jQuery. A site using the HTTP version of the framework will also run the backdoor code, allowing the attacker to control that website as well. To secure against PoisonTap as a web server, it's critical to use HTTPS exclusively. Always ensure the secure flag is enabled on cookies so they don't leak to an HTTP site, and also enable HTTP Strict Transport Security, or HSTS. To protect a client machine, I suggest adding cement to all of your USB ports. Also, if your machine supports file system encryption, such as File Vault, enabling it and putting your system to sleep each time you leave is the current solution, as the browser won't be running in memory when accessed. I've released all of the code for PoisonTap, along with an even more detailed explanation of the attacks and security on my website at sammy.pl/poisontap. If you enjoyed this video, please hit like and subscribe. Also, you can join my mailing list by clicking here. Thanks. Bye.